All right, welcome to biology. All right, I promised you guys I would make this video. The topic that we'll be covering today is chemistry. Now, I said that chemistry is one of the hardest chapters for most biology students because at this point you haven't had really much chemistry at all, if none at any. So it was kind of hard to understand and some of the concepts, but let's just talk about some basic chemistry and what do we know about some things. Let's do some review. We know that we know like the shape, okay? We know that excuse me, that the atom has a shape. We see like pictures and drawings of this, and you know, and sometimes we'll see like a picture of like this and like that, and we kind of see like these things, and there's these little particles attached to these, and so all right, so that there we go. We know that structure there is an atom. Okay, hey, that's an atom. All right, so no, we've all seen this picture before. I drew the color specifically for the blue in an atom is a proton. Okay. And I'll try to stick with these colors as I go through the presentation when describing things. And of course, the red is a neutron. And lastly, the yellow dots, the lines are just how it's orbiting. And lastly, these are the electrons. Electrons, all right. So those are the three things that make up an atom, okay? Protons, neutrons, and electrons, all right? Now, there are some characteristics of a proton, okay? So, proton. Well, one thing about a proton is it's a positive charge, represented by a plus, so that's positive, okay? And it has a weight, and it weighs 1 atomic mass unit, okay? Now, next we have a neutron. Neutrons have no charge. I put an N there, or a neutral charge. Of course, I can remember neutral by the letter N, and then going back up here again, positive for proton, so the P and the N. And then, of course, the neutron has a weight of 1 atomic mass unit. Okay? Those are the two particles that make up the nucleus. Okay? So you can see here that the protons are in the center and the neutrons are in the center. And that makes up a thing called the nucleus. Nucleus of an atom. Okay? And then lastly, we have the particles orbiting the outside of the nucleus, electrons. And those have a negative charge. And they don't have much weight. They basically are considered almost weightless, so 0 atomic mass unit. All right, so make sure that you know that protons are positively charged. Make sure that neutrons, that you know that they have a neutral or no charge. Make sure that the electrons, you know that they have a negative charge. And then, of course, make sure you know the weights. So 1 atomic mass unit for a proton and 1 atomic mass unit for a neutron, okay? These things will come back up later, so it's going to build upon itself. So kind of like math. So, but we're going to move on. Give me 1 second to get a fresh workspace. All right, here we go. All right, so one thing in chemistry that we talk about is a thing called matter. And the easiest way to think about matter is, should you matter about something? Yes, because everything is made up of matter. Everything. Now, what is matter made up? Matter is also made up of atoms. Remember those structures we just drew? Made up of atoms. Okay, and those atoms, can be certain elements. And of course, matter can be in a few forms: a solid, a liquid, a gas, and a plasma. And the plasma is like outer space stars, so don't really need to focus on that. But you need to know that matter is made up of atoms, and everything is made up of matter. So, some examples down here. I'm going to draw a baseball. All right, we got a baseball there. I'm going to draw a virus. So, like, I don't know if this could be the flu virus here or any type of virus. Just doesn't matter which one, just a virus. So there's a virus. And then what could I draw over here? I'll just draw a human being, or just a smiley face for. All right. So these three things: a baseball, a virus, and human beings. Which one of them is matter? Okay, so let's look at the baseball first. Does the baseball have a mass? Oh, that's one thing I forgot to add. Matter has mass. Sorry. All right, so does the baseball have mass? Yep, sure does. So right then and there, we know that it's a form of matter. We also know that it's made up of atoms because obviously a baseball exists. There's carbon and all types of other little things inside there that make up a baseball. So yeah, it's matter. Human beings, do we have mass? Sure do. We made up of atoms? Sure are. Are we a solid? Part of us, yep. All right, so we don't necessarily have to fit all these criteria, just one of these. And then lastly, a virus. Ooh, kind of tricky. Does that a form of matter? Sure is. Has mass. We can't really weigh it because most of the time we step on a scale in our bathroom, but it does have a mass, and it's made up of atoms, so it's matter. So yes, all of these are matter. So everything pretty much on Earth is a form of matter, and that matter is made up of atoms. Atoms. All right, let me get a fresh workspace here. So talking about an atom. Atom. It is the fundamental building block of everything. All right. And atoms also determine what something is. For example, carbon or oxygen. All right. And of course, the atom is represented by the drawing that we did earlier with here the protons, and then we got the neutrons, and then we have the electrons orbiting the nucleus. So there you go. So just a real quick drawing of an atom. There we go. So hopefully that should look somewhat familiar to some people. But and of course we know the three particles that make up an atom. So Three particles that make up an atom. Proton, neutron, and lastly, the electron. Now here's a good review. Right now, you need to be thinking to yourself, what are the charges on these? All right, so do you remember what electron was? Negative charge. Do you remember what a neutron's charge was? No charge or neutral charge. And lastly, do you remember what the charge of a proton is? Positive. All right. So there is an atom. Hopefully that should be just some kind of review for you. All right, let's move on. Let me get a fresh workspace here. All right. Now, if you don't already, you need to become friends with the periodic table. Okay. The periodic table tells us a lot of information. Okay. And one of the things it tells us is the elements. Okay. So, for example, I have this element here. And let me think of another one. Okay. You can also Google a periodic table and look at that, or just open a book. Maybe you have a chemistry or biology book. It should be in there. So I'm just drawing three elements from the periodic table. Okay. And none of this information I'm drawing here is hard to find. As I said, you need to become friends with the periodic table because it gives you a lot of information. Just make sure you know how to use the information. So there we go. We have three elements there. Okay. And those elements are represented by a symbol. And the symbol tells us what it is. Tells us the element. So C is carbon. N is nitrogen. And O is oxygen. All right. And the way I got that symbol is right here. This is considered the symbol. That big letter on all three of them. So the C, the N, and the O. Okay. Hopefully that should just be a review. If not, no big deal. All right. Now we need to start getting into what these numbers mean on the periodic table. You see, I have a 6, a 7, and an 8. Well, what is that telling me? Okay. It must have some significant importance. Okay. That's called the atomic number. Okay. Atomic number. Well, what is an atomic number? It is telling us the amount of protons in that element. All right? Straightforward, plain and simple. So if I have carbon, all right, I need to look and see how many protons are in there. You just look at that number up there from the periodic table. Don't need to memorize it. Just Google the periodic table. So you know right there it has a 6, so that should tell you it has 6 protons. All right, so nitrogen. Real quick, how many protons are in that? Well, just look at the periodic table and look at the atomic number, 7. Okay, and then lastly, oxygen is 8. All right, so the amount of protons in an element. So keep in mind, when we're talking about chemistry and things building upon each other, when I said proton, you should start thinking positive charge, weighs 1 atomic mass unit, is in the nucleus. So keep things in mind when I say stuff like that. When I use the word proton, start thinking about stuff. And lastly, what is this number down here? This 12, 14, and 16. What is that? Well, that's the atomic mass. All right? Atomic mass. and that is the average weight of the element. Now, for currently where we're at right now, all intents and purposes, just know that as the average weight. But make sure you focus on the word average. And we're going to be talking about average, this average weight. Why did we say average weight, not just the weight? Well, we said the average for some reason. And I'm going to explain to you why. But once again, you can get that atomic mass from the periodic table. No fancy rocket science, just look at the periodic table, and there you go. So you can see here that carbon has 12 atomic mass unit weight, and nitrogen has 14, and oxygen has 16. All right, got that straight from the periodic table. No, nothing fancy there. Okay, so once again, these up here, these are the elements, and we found that on the periodic table. Okay, so let's move on to the next topic we're going to talk about. All right, let's get a fresh workspace here. All right, so the next thing we're going to talk about is, let's talk about isotopes. Okay, isotopes. Now remember how we were just talking about that atomic weight? This is when it's going to come into effect. So what is an isotope? It's an element. So, carbon, oxygen, nitrogen, whatever the element may be, whatever element, does not need to be these three, any element. An element with the same number of protons. Okay? But different number of neutrons. All right, so right there when I said proton, you should start thinking positive charge, 1 atomic mass unit. Then when I said neutron, I said you should thought of no charge, 1 atomic mass unit. Okay? Now remember, when we first learned what an atom was, we learned that it looks like something like this, and we have the protons and the neutrons in the nucleus, and we have electrons orbiting the nucleus. All right? That was our atom there, and that's so. But what can change is an isotope. So when I said, if we look back at the periodic table, and let's look at what we had. We looked at carbon. Okay, carbon was represented by number 6. Remember, we got that from the periodic table. C represents what it is, so carbon, and we said it had an average weight. An average weight. So right then and there, we know weights. We know that this has a weight, and we know this has a weight. Okay? So when we're trying to figure out isotopes, so like for example, I could say carbon 11, carbon 12, and carbon 13. These are all carbon, okay? All carbons. So draw my. These are all carbons, but what makes them different is the number of neutrons. So they're considered isotopes because they have different number of neutrons. So this one has an atomic mass unit of 11, this one has 12, and this has 13. So let's look at and break that down, the isotopes. So let's first look at carbon 12. Well, remember, it's the same number of protons, okay? We can't change the number of protons. If we change the number of protons, we physically change the element. And we don't want to change the element. We want to stay with carbon. So we do not touch the carbon. We do not touch the protons. If we touch the protons, we're changing the element. So do not touch the protons. All right, so we know here from the atomic number that we have 6 protons. Perfect. And remember, positive charge. Now I'm just stretching this out. This, remember this is inside the nucleus. All right, and so remember each proton weighs 1 atomic mass unit. So of course down here we see we have 6. So we have 6 atomic mass units for our weight. All right, so what was the other thing that gave us weight? Wasn't electrons. Remember, they had no weight at all. It was neutrons. Now we're trying to get to 12. This isotope carbon 12, okay, carbon 12. We're trying to get to this isotope here. Well, simple. Just do 12 minus 6 gives you 6, of course. That would be 6 neutrons. Neutral charge or no charge, no charge, no charge, no charge, no charge. All right. So 6 atomic mass units, 6 plus 6, we know is 12. So 6 plus 6 is 12. All right. Let's look at, no, that was for carbon 12. Let's look at the isotope carbon 13. Okay. Well, once again, don't worry. I give you carbon 13, and we know that I give you the number 6. So remember, we have the same number of protons in the element. Okay. So draw 6 again. All right. All positive charge. 6 atomic mass units. All right. Perfect. So what do we need to do to figure out how many neutrons are in this? Well, just simply do 13 minus 6, 7. And so that means we have 7 neutrons. Of course, neutral, 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 neutral. So 7 atomic mass units, or neutrons. All right. So isotopes, once again, it's the same element. It's just a different version of the element. So it's kind of like saying like Windows, 1.0, and Windows 2.0, Windows 3.0. Okay. So when we go back and we look at the periodic table and we see that number underneath it, let me see here. Let's go back. So when we go up here and we see right here, this number 12, this number 14, this number 16, remember I said the atomic mass is the average weight of the element. That average that they're getting is these isotopes down here, different versions of carbon. So if you add these up, divide by 3, you get 12. Okay? Take 11 plus 12 plus 13, divide by 3, you get 12. So essentially that is the atomic mass is the average weight of the element. So there's 12, 14, and 16. So obviously there's different versions of oxygen and nitrogen and carbon out there, but there's still carbon, nitrogen, and oxygen. They just weigh a little different. And that's all an isotope is. All right. Lastly, brings me to the topic of charges. All right. Charges. Right now you should be thinking in your head, I already know some charges. Positive charge. Who's that? Who's that again? Proton. Of course, then we have a no charge or neutral charge. Neutron. And then, let me see, proton positive. And then lastly, we have a negative charge, and that is a electron. All right, so positive, no charge, negative charge, okay? Sometimes people get Don't fall into the pitfall of thinking N means negative. N means neutral or no charge. Sometimes early students just learning chemistry fall prey to this. It's the electron that has the negative charge, not the neutron. Okay? So when you write an element, you may see people in chemistry or in a book that has something like sodium plus. What's that? When I look at the periodic table, all I see is just Na, just sodium. So what does that mean? I don't know. Well, I'm going to show you what the plus means, okay? And for all intents and purposes of drawing, I'm not going to use sodium, but let's use we'll just use carbon. Carbon's always fun. So draw carbon up here again. Remember C's atomic number 6. And then of course our atomic mass is 12. All right. So you're trying to figure out the charge. So you're trying to figure out, like, if I give you this Na plus and I ask you to say, well, can you tell me in Na plus how many electrons are in there? You're sitting there thinking, oh my goodness, how do I figure out how many electrons are in there? But for example, let's say carbon plus, and I ask you how many electrons are in there, are in carbon plus. And you're sitting there thinking, oh my goodness, I have no clue. Well, actually you do. What do you know already about carbon? Well, you already know carbon has 6 protons. Okay, so let's draw 6 protons. 1, 2, 3, 4, 5, 6. Okay, 6. There's our 6 protons. Okay, so we're doing good. 6 protons. All right, so we got that. And we're not so much worried about the weight, so we don't need to worry about the atomic mass. Well, let's first things first. Whenever you're trying to figure out a charge, I guess right up here, I'm going to star this in pink. Whenever we're trying to figure out a charge on an ion, so we're trying to figure out the carbon plus, we're trying to figure out the charge on that ion. When you're figuring it out, draw out your protons, and then here we go. Make protons equal electrons in the amount. I ran out of page. All right, so first thing I need to do is make the number of protons equal the number of electrons. So I have 6 protons. I need to make this have 6 electrons, okay? Now the principle that I'm going to be using here is just simply like math. So if I have 1 subtract 1, what does that equal? Equals 0. So if you look right here, we have 6 protons and 6 electrons. So 6 minus 6 is 0. Okay? 6 minus 6 equals, I'm trying to keep my colors straight for you, equals 0. Okay? So let's look at this. Now we need to focus on this charge. The charge is this plus. All right, so how do we get a plus? Oh my goodness, Mr. Gunder. I don't know. All right, so the way we do that is this. We know that in chemistry, the electrons are responsible for bonding and reacting with other elements. Remember, we've seen people mix things and reactions occur, something explodes or something gives off heat or whatever it may be. Those are responsible for the electrons. The electrons, and we'll learn in the next section, bond with other elements. So they are the ones who leave, okay? So if we have this electron here at the end, let's say he leaves. He's going to go bond with something in the reaction, okay? So now we no longer have this electron at the end here. So let me try to try to erase this real quick. So, all right, so we no longer have this electron, okay? It is gone. It went off to bond with something. I'm not concerned right now what that something is. But now let's look. Let's count up how many positives and how many negatives we have. All right, 1 second. All right, so 1, 2, 3, 4, 5, 6 protons. We don't touch the protons because we're still talking about carbon. Okay, we're not talking about some other element. We're still talking about carbon plus. That's what we're trying to figure out. Well, we know carbon has 6 protons, so we have 6. We have a plus 6, and that plus is represented by 1, 2, 3, 4, 5, 6 positive charges. Okay. Then let's add up our negative charges from our electrons. 1, 2, 3, 4, 5. So we have a negative 5. Negative is the charge. Negative 5. Well, you just do some simple math there, and we're going to see that we're going to have a plus 1. So we're going to have a positive, and that positive proton that's left corresponds directly to that charge. So all that plus is saying there is how many electrons you have or how many electrons you lost. So let's take the same example and let me scroll down here and get a fresh work area. Same principle. We're still talking carbon. Okay, let's not even change carbon. So now I'm asking you carbon minus. And I'm asking the same thing. How many electrons are in carbon minus? Remember that that minus or that plus is representing a charge. Those charges are representative of the protons and the electrons. All right, so we know we're still talking about carbon. I still said carbon. So we know that carbon has 6 protons from the periodic table. Positive charge, positive charge, positive, 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 positive. So we have a plus 6 charge. Remember the golden rule? Make protons equal the amount of protons equal electrons. So first things first. So we need to make that 0. So 1, 2, 3, 4, 5, 6. All right, so that gives us a minus 6. Minus, 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 minus. And all we did there is make carbon with no charge because these are canceling out. Remember, plus 6 minus 6 is 0. But now we have this carbon minus. Well, remember, we said electrons are responsible for reactions. They can give electrons away. Remember, in the previous example up here, we gave an electron away. So we gave an electron away. In this example, carbon minus, we're going to accept an electron. So here's an electron, and it's going to come in and bond. So now we have this extra carbon, or this extra electron, excuse me. And it came in from some reaction. So now we got to add up 1, 2, 3, 4, 5, 6, 7. We no longer have a minus 6 anymore, correct? Okay, no longer have a minus 6 because we add up all those carbons. Let me do an eraser here. All right. 1 second, just adjusting some things. All right. So 1, 2, 3, 4, 5, 6, 7. Minus 7. You do some math here. You see that we have a minus 1 or a negative, and that charge, that minus 1, is representative here with a negative on the carbon. So when you're finding out charges, all you're doing is finding out the number of electrons. Okay? And just remember, the easiest way to figure this out is to draw it out like I did here. Draw out the number of protons with positive charges, and then make it neutral, so draw an equal amount of electrons, and then add an electron and then take away an electron, and see how the math adds up to give you a plus or a minus. And the same thing can be done if you have in life, calcium plus plus. So all that double plus, that means there's a 2. Okay, so that right there, you should start thinking, if you use this math above here, you'll be able to figure out how many electrons are in this. And of course, we know calcium from the periodic table has 20 protons. Okay, so from 20 protons, we can start taking away electrons and seeing how many electrons are in calcium plus plus. Of course, 1, 2. All right, well, I hope that was helpful. Please leave me any comments or ask me any questions that you may have. And other than that, hopefully you found this educational. Thanks.